All right, hey guys, let's do another Leetcode question today. As is tradition, we're going to do an easy and one I haven't done before. We'll choose something at random and we'll start the timer. I'll be using a Google Doc, still pain, because that is how a lot of interviews tend to end up. Not Google Doc, maybe Notepad, maybe Quip, who knows which company you end up with. And it's important to be able to have all the knowledge you need to write the basic pseudocode / code out in a Google Doc. You don't have to have the syntax being perfect, but it's important to know what you're doing and should look like you know what you're doing. So let's start with this question. 2057, smallest index with equal value. All right, so we got an array, nums. Find the first index, the smallest index, such that that index I modulo 10 is equal to the value at I at that index, or -1 if it doesn't exist. And it just explains how mod is the remainder when you divide x by y. And thankfully in Python, it's as simple as using the %sign. So let's see. Sorry, just burped. All right. Let's have a look at the example. We get 0, 1, 2, and output is 0 because 0 mod 10 is 0, which is equal to the value at 0. Here, if we had num 0, 1, 2, index 2 mod 10 is going to be 2, I think. And therefore, we return that. And we return the smallest index of I. The smallest index I, not the smallest value. But I think that would by default have to, well, maybe not because of the mod 10. So let's just talk this out. The smallest index I means the first value, basically the leftmost value, where this value is true. So immediately what I'm starting to think about is smallest index I is leftmost. So iterate over this array. First success return is what I'm starting to think, because we can basically stop as soon as we have our first success. The array is not sorted, I don't think. Yeah, it doesn't say anything about a sorted array, so no matter what, I think we're going to have to iterate. Well, do we have to iterate over the whole array? Because once you get past 10, 11, the value itself could still be some number that is mod 10 equal to 2. So like, say at index 10, the value is 0. That would be a valid index that is equal value. We can basically throw out anyone that has a number greater than 9. The values have to be between 0 and 9 to ever work. And in fact, that's the case in our inputs. And the length of the array, again, is 1 through 100. There's an argument for the interviewer might extend this question and ask what happens if you stream in an infinite sequence of values. How do you deal with that? Doesn't seem to be a big issue here. And then you return -1 if it's not any of those things. So -1 if none found. So I think we can just kind of start thinking about our first approach. We do exactly this. Iterate over the array, and the first success return, and success is just defined as this function call. That's going to be O of n for number of items, number of ints in this array. Questions to ask the interviewers: are all the values going to be valid? Could we have floats, anything weird? Do negative numbers change this in any form or fashion? And with our constraints, we don't have to worry about any of these things. We also don't have to worry about an empty array. So no empty array checks, but in an interview, you need to ask these questions so you handle edge cases. All right, so let's just create our function. We'll call this smallest. In fact, we can see it right there, smallest equal, and the values will be nums, which is going to be a list of int. And our output is going to be the index, which will be an int. Another thing to kind of keep in mind is, like, if the length of the array, this int max int size, we start having issues. Not the case here because the max size is 100, but good to note. Usually the interviewer will not worry about that. but they'd like to, if you say that, that's probably an extra point. So we'll just iterate over the array. For I in range, or for I val and enumerate, this will give us both the index as well as the value. We'll do a check. So if the index modulo 10 is equal to the value, we're good. Return that index. Otherwise, we return -1. I mean, I think that's it. This might be a really short video, but here we are. Wait, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, because it's off by 1. That's fine. Trying to think of any edge cases I might be missing. I mean, besides the fact that we know we don't have to worry about an empty list and so on. This is going to be the O of n and nothing special there. Modulo operation is O of 1 in this case. And we're not storing anything extra. Time O of 1 space. So that's one. Let's see if we can do a quick optimization. We could, or not even optimization, we could just kind of inline it. Return I. Is this even worth doing? Probably not. This is for people who want to feel clever, I suppose. So that's me at the moment. So sorry. Don't worry, I know I'm not that clever. So feel free to roast me in the comments as you want. So here I'm just basically taking advantage of Python's inline function calls, where you can kind of create a list by using a for loop within, and the value will be whatever's in here, which I wonder actually if Python allows you to put a return statement inside something like this. I have a feeling you're not allowed to do this, but let's just see if we can even do that. And otherwise we return -1. And you have to wrap it in some sort of list or something, otherwise it won't create a generator like that. Let's just try it. Let's see what we get. I'd love to see this work, but okay. So let me see if you guys can actually see this also. Here we are. Let's make the size a little larger. Okay. Let's check if this return I works in line. I'm not entirely sure if Python allows that. Yeah, it doesn't look like it is the case. That's okay. This is why we have the actual solution over here. And we need to get rid of all the tabs. Copying from a Google Doc is the worst. So returns the index if it's that value, which is what we want, this index where it's equal. And they don't actually care about anything except for the index. Okay, let's try it. Oh, hold on. This return needs to be outside. Sorry about that. There we go. So it looks like it was accepted for the test cases. Let's do a submit and see what we get. So fingers crossed. And it's accepted. Cool. All right. As I've said in every other video, don't bother with the runtimes. Sure, if you want to try to optimize for the Leetcode game, feel free. That's not what my videos are about. Optimizing for Leetcode has very little to do with optimal algorithms or good coding practices and what actually becomes optimal when you're doing things in big data. It has all to do with taking advantage of how the backend interprets the code and blah, 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 and whatever C types I use. Like there are some function calls in Python that uses C in the backend and some that don't. Even if it's more efficient algorithmically, it's better for the question. So I'll get my soapbox for that one as well. But if it is extremely inefficient, you will start to see it. So that starts to come into, that starts to matter when you get into the medium questions and so on. But happy to see that this one was pretty straightforward. We could do a quick extension here since we've done this in about 9.5 minutes. So let's pretend the interviewer is happy with what they've seen and they ask for an extension. And the extension is the streaming idea. Stream of infinite stream of ints coming in. Return once, return anytime it's true. Is that valid? Is that useful? It's not that interesting. I'll put a link to the previous video where I talk about this concept. I don't think it's necessary to do here for this specific question, because the question is about the first one that you get, and just returning anytime is true is kind of a straightforward problem. So I'll skip that here. Let's see, what else could we do? What if we had a bunch of checks rather than one? So let's get rid of this for now. Or what if we provided a specific set of checks? I don't know. Yeah, okay. What if instead of it's just modulo 10, we pass in not just the 10. So let's say our input is now going to be something along the lines of modulos or divisors, and it'll be a list of ints. And now we need to do the same thing, but we're checking for all of those values. So I mean, this essentially just becomes another for loop for divisor and divisors. And actually, okay, there is a slight optimization here. So we can do if I divided by divisor is equal to true. Instead of doing that, we do it for every divisor, and then we check that all of them are true. If all of them are true, then we return. And so we can take, this is like at least one little thing that we can say is kind of fun. So this becomes O of n, and let's pull this up here so you guys can actually see what's going on. Yeah. O of n times k, where n is num length, k is divisor's length, because we have to do a check over both. And we've just taken advantage of the all call that checks over all of the values inside of a generator function, such as this for loop, and make sure that they're all true. And let's just clean this up. Let's get rid of all the spacing. There we go. Can we do better than that? Yeah, we might be able to actually. Well, yeah, we should be able to, because what we could do is a preemptive step, remove divisors that are divided equally by smaller divisors. So for example, if you have divisors is equal to, our original was 10, but let's say we also had a divisor of 5. Any divisor that is modulo 5 is equal to 0. Oh, is equal to val. Never mind, that doesn't apply. Okay, there probably might be fun mathy things here. Not really relevant to the scope of an interview, unless that's the point of the interview. I have had some questions on whiteboard where we had to go into the math of things like this, but that was the whole interview and not including this coding step per se. So probably outside of the scope of this question. Anyway, I think this was a pretty fun one. I enjoyed it. I think it's a good warm-up for a completely entry-level candidate. Good sanity check. Make sure to just practice doing this yourself if you're just getting into coding. And all right, see you guys next time. Cheers.